The ignition systems used on today's vehicles fall into two categories: wasted spark and coil per cylinder. A strong knowledge of these systems will enhance your diagnostic capabilities. The idea of introducing more than one ignition coil to an engine is very clever, as it has several key benefits, such as the elimination of the distributor and any moving parts associated with it. This helps enhance the overall reliability of the ignition system. Also, we now have electronic control over spark timing advance and have eliminated mechanical adjustments to static timing. Because there is no distributor and therefore no distributor cap, problems such as radio frequency interference and misfire due to excessive rotor to cap clearance has been eliminated. More ignition coils for the same number of cylinders allows for greater saturation time and more stable operating temperatures. A wasted spark ignition system uses one ignition coil for two spark plugs. Both ends of the coil's secondary side are directly connected to a spark plug. This means when the coil is triggered, both plugs are fired at the same time. There are two ignition coils on a conventional 4-cylinder engine, so the pairing would be 1 and 4 and 2 and 3. Using a wasted spark system, a 6-cylinder engine would have 3 coils and an 8-cylinder would have 4 coils. An ignition module is still generally used for triggering the ignition coils, but later versions receive their control direct from the ECM. The control module synchronises the coil's firing sequences in relation to crankshaft position, camshaft position, and the engine's firing order. The ignition coil primary current is operated by switching transistors in the control module. These transistors or drivers complete the ground path for the circuit. When the primary current is interrupted, high voltage is induced in the secondary windings, causing current to flow in the circuit. The dwell or coil saturation time is limited by the control module. The module is programmed to only allow total coil saturation when high current is needed. This limiting prevents heat from being produced, prolonging the service life of the ignition coils. Using the inputs from the fuel management system, spark advance can be calculated to allow for all engine load conditions. In a wasted spark system, the ignition coil is connected in series with 2 spark plugs. Due to the design characteristics of the coil, one spark plug will fire from the centre electrode to the ground electrode, while the other fires from the ground electrode to the centre. These ignition events are timed to occur on compression and exhaust strokes of paired cylinders. Whenever an ignition event occurs on the exhaust stroke, it is said to be wasted, as this event does not contribute in any way, shape or form to crankshaft torque or emission control. You might think that firing 2 plugs at the same time will overwork the coil, but it's not the case. Because one cylinder will be on the exhaust stroke during the ignition event, the spark plug air gap resistance will be low, requiring very little voltage to fire. This leaves plenty of available voltage for the other cylinder on its compression stroke. A nice, easy test for a wasted spark coil is to remove both spark plug leads and activate the starter motor. To overcome this air gap, the coil must produce around 50,000 volts. The operation of a coil per cylinder ignition system is basically the same as any other type. By definition, there is one coil for each cylinder. There are 2 different types of coil per cylinder systems used today: the coil over plug or the coil near plug type. The main difference is a coil near plug type needs a high tension lead to connect the coil to the spark plug. These systems are used when the location of the spark plug does not allow enough room to mount individual coils over the plugs, or when the spark plugs are too close to the exhaust manifold. By using a separate coil for each cylinder means they only need to operate every second crankshaft revolution. This allows for more cooling, longer saturation, and be more effective at igniting lean mixtures which require a very high output voltage. Another advantage of a coil per cylinder system is that the spark timing can be individually adapted at each cylinder for all operating conditions. Individual cylinder detonation can be controlled using the misfire monitoring system combined with NOx sensor feedback. Unlike wasted spark systems, high tension current always flows from the centre to the ground electrode. In a typical coil per cylinder ignition system, the crankshaft position sensor provides the input data used to calculate basic timing points within the ECM. The ECM is programmed with the engine's firing order and determines which coil is due to be triggered. Additional data inputs from the camshaft position sensor provide which stroke the piston is on. There are two common types of overplug ignition coils in use today. A standard type coil overplug has two primary terminals only. These operate identically to a conventional coil system, using an ignition feed to the positive side of the low tension circuit and the trigger signal on the negative side. The secondary circuit is identical in design but can be constructed much smaller than a conventional barrel type coil. However, this type of coil overplug requires heavy-duty solid-state drivers to trigger the primary circuit. These may be identified by the number of terminals in the harness connector. These ignition coils contain a solid-state driver module as their primary element. A trigger from the ECM enables the driver circuit to initiate the ignition event. Ignition voltage is then applied to the low-tension circuit for the dwell period. This is adjusted for the operating conditions. The ECM deactivates the driver circuit and ignition current ceases to flow through the low tension windings. Current is induced in the secondary windings and fires the spark plug. The only way to effectively test this type of coil is with an oscilloscope. On the primary side, we can check ignition feed, grounds, trigger pulses from the ECM, and even feedback for fault diagnosis. While the secondary can be checked with the coil unplug probe. The ignition coils used in today's vehicles have been designed to operate dependably and reliably under all engine operating conditions. They function throughout the entire speed range to help manufacturers meet emission, fuel economy, and performance targets. Remember to keep training. It's the only way to stay ahead in this fast-changing industry. Thanks for watching.